Well, our guest tonight is Mr. Marcus Allen. Now, he is the UK publisher of Nexus Magazine, which covers UFOs, hidden history, and conspiracies, just to name a few. And the moon landing is just one of the taboo subjects that he has investigated and which new questions have been raised that have yet to be answered.
Well, Marcus, welcome to the show. I know it's late in the morning there in the UK. How are you doing?
I'm very well, Gary. Thank you very much.
Well, welcome to the show.
Indeed. I look forward to your hard questions about my personal favorite subject. Did we land on the moon?
I mean, how old were you when you started getting interested in this stuff?
Well, I first really started getting interested back in the 1960s. I'm old enough to have been around when those happened, and most of the stories are true, by the way. And the first book I came across was quite a famous one. It's called Chariots of the Gods by Eric von Daniken. It's quite an interesting book in that it's looking at ancient civilizations and why don't historians talk about these things more openly. And that sort of got me interested in other areas. And the moon landings followed. That was 1990. I was first aware that there were problems. I mean, I'm old enough to have been around to have watched it happen live on television. I expect some of your listeners will have been around at the same time. I stayed up. It was 3:30 in the morning in London, where I was living at the time. And this extraordinary adventure was taking place. Man was going to land on the moon. I thought, I've got to watch this. This is history in the making. And I watched it, and like everybody else, I was amazed at the incredible achievement. And for 30 years, I believed that what we were told was true, that man had landed on the moon. I mean, we saw it on television. It must be true. It was then I started hearing people questioning it. I say about 1990 this was. I attended a lecture down in Glastonbury. You've probably heard of Glastonbury, where the music festival is held, but there are plenty of other things go on in Glastonbury throughout the year, and one of them is called the Glastonbury Symposium, where people get together and discuss these sort of subjects. And this particular person is actually an American, and he's showing photographs of megaliths and megalithic sites, and there are plenty of them around. And he said, almost in passing, he said, well, of course, you've probably seen the pictures of those chaps on the moon. Of course, they aren't real. They were taken here on Earth. They couldn't have been taken on the moon. It was some time before I discovered why they couldn't have been taken on the moon, and we'll come to that later, I'm sure. So that set me off in trying to work out what was going on, because I was trained as a photographer in London in the 60s. So I knew what cameras could and couldn't record. I knew what film could and couldn't record. And it's an important point to make here. We're talking about photographic film. We're not talking digital cameras. They weren't invented at the time of Apollo. The first digital camera came along in 1975. So they were all taken on photographic film. And if you've ever used photographic film, whether it's black and white or color, you'll know that you have to get your exposure pretty accurate. You can adjust the processing of the film. As I say processing, it's nothing to do with computers. It's all to do with chemicals. So you take your film, put it in the camera, take the photographs, take the film out of the camera, put it through chemicals, develop it, and then from that you can create the images on paper if you want to. You can enlarge them. And so it's a complicated process. It's not like today's cameras where you just point and shoot it.
Marcus, too, again, if I remember right, they were shot with a Hasselblad, with a motor drive, with a film pack, which not like a roll of 120 or 220 film. They had a lot of exposures. But you're right. You had to set the shutter speed. You had to adjust the aperture. Again, is this so when you look at those pictures, they're so sharp. So the exposures are dead on. Just like you, I shot professionally. I've been in radio all my adult life, but I also been a professional photographer. And I know what's involved to get a good exposure, especially when you start getting into medium format and stuff. It's really critical. I mean, especially where you have the contrast of like on the moon. Am I correct?
Absolutely correct, yes. It's interesting that you are familiar with cameras and you've used photographic film. So you'll be aware of some of the problems that I might highlight about that photographic film. If you've only used digital cameras, you're not really aware of how difficult film cameras are to operate. As you say, It was a Hasselblad camera that was used. That was one of the very best cameras you could buy in the 60s when it was decided to use them. It's one of the very best cameras you can buy today. They cost $45,000, by the way, today. They're very expensive, and most of the money goes on the lens, because it's the lens which is the key to getting the resolution, which is the sharpness of the image and the information within the image.
For a lot of people that go out and have a point and shoot, or even a non-point and shoot, like a DSLR, the quality of the lenses compared to what you would find on the Hasselblad type lenses. I mean, let's face it, I did portraits where you could see the hair follicles. You could see things that if you try to do it with a digital camera, you wouldn't even see.
Yes, it's the equivalent of a 50 megapixel image in today's technology. It was quite possible to record something at that level of resolution back in the 60s. The Hasselblad camera is like a Swiss watch. It's beautifully made. It's incredibly complex. It has gears. It has, as you mentioned earlier, it has an electric motor drive. It's the only automatic feature on that camera. It just wound the film forward. Once you press the shutter button, the film would automatically wind on to the next image. But you had to set the aperture setting, that's the f-stop. You had to set the shutter speed, that's the 1/25th, 1/250th, and you had to focus it all by hand. And you could do that usually by looking through the viewfinder, because the viewfinder was there to assist you. But on the Hasselblad cameras used on the moon, there was no viewfinder. It was taken away. Because if you were wearing a spacesuit, you couldn't get your head down close enough to the viewfinder, which is on top of the Hasselblad camera, to see what was there. So you just had to put it onto your chest and move your whole body to get the picture you wanted. Well, how many people have actually tried that? Well, I've tried it. It's very difficult to get it lined up accurately.
Yeah, without sagging left and right and every which angle.
Yeah, and make sure you don't cut somebody's head off, because there's no point in taking a picture if you're going to cut somebody's head off. And you're wearing a spacesuit, which means you've got armored gauntlets, or the equivalent of armored gauntlets. So you can't feel anything. And as I said, you press the shutter on a Hasselblad camera, the shutter is on the front of the camera, just below the lens. And you can't see that from inside a spacesuit. The film counter, which tells you if a photograph has been taken, is on the side of the camera. You can't see that from inside a spacesuit either. And obviously in space you can't hear anything. So you've got all these limitations of use, but some of the most iconic images of the 20th century were taken. No, they weren't. Not on the moon, they weren't. They were taken here on Earth under controlled conditions by professional photographers. And if anybody can prove me wrong on that, I'd like to hear about it, because for 25 years I've been asking somebody to prove me wrong. They haven't.
They can't.
Well, they can't, because there's no way that you can actually conclude that the photographs were taken on the lunar surface, because there are various other problems with going to the moon, which we'll come to us in a minute, most of which cause terrible problem with photographic film. The first one, obviously, is radiation. We all know that radiation damages photographic film, which is why when you going through customs security many years ago, if you had a photographic film camera, you were told to ask for it to be hand searched. You didn't put it through the X-ray machine because that would damage the film. Yes, it did.
It fogged it, if I remember right.
Yeah, it would fogged it. Basically, it reduces the contrast on the film. Certainly on the moon it does, because there's no protection on the moon. There's protection here on Earth. There's our atmosphere that protects us, and there's the famous Van Allen radiation belts, which are about 1,000 miles above the Earth's surface. They protect the Earth as well. Beyond the Van Allen belts, 25,000 miles out, there's no protection. Space is full of radiation. In fact, when James Van Allen, who was after whom the belts are named, is Professor James Van Allen of Iowa University, he did the first experiments to demonstrate that the belts existed. He'd calculated them theoretically, but he wanted to prove that they physically existed. So the very first rocket that was launched in America, called Explorer 1, carried a Geiger counter on it. That's how you measure radiation. And the Geiger counter started to indicate that there was radiation in space, and then it stopped working. Whoops. So when they got it back, they decided that they hadn't set the readings high enough and that the Geiger counter had been overwhelmed. So they sent another one up, and that demonstrated that as well, that there was radiation in space. And as James Van Allen said, space is radioactive. Well, radiation affects photographic film, but we don't see any of that on the 5,771 photographs taken by the named astronauts on the lunar surface over the 6 missions we're told Apollo landed. There were 3 that didn't land, and we'll come to the Apollo 13 conundrum maybe later, because that's a real story, really interesting story. So the 5,771 photographs taken on the lunar surface, not one of them has radiation damage. Some of them are not very interesting, some are a bit out of focus, some don't show very much at all, but quite a lot of them are good photographs. Somebody who was taking these photographs knew how to frame, focus, and expose correctly a photograph.
Well, here's the thing, Marcus. When they were photographing, like Buzz, for example, they're concentrating on looking, because they're on the moon. They're seeing what's going on, plus they're looking for their own safety at the same time. So how are they going to get all these beautiful, for a short period of time being on the moon, to get all these sharp images and perfectly framed ones, which, again, I don't understand. And, Buzz here recently, I don't know what is going on with him, but one day he contradicts that we never went to the moon. The next day he's coming out and saying, well, some of the pictures were staged. They were taken on Earth. So, it's frustrating.
It is. I actually feel quite sorry for Buzz, because he's suffered quite a lot in his personal life. He's been divorced several times. He was an alcoholic for a while. He had depression. Obviously, there's a lot of things going on that we're not privy to. But he is considered to be one of those famous Americans who set the standard for the future. Here's a question. Neil Armstrong died in 2012. He's buried. Do you know where he's buried?
No.
One of the most famous Americans in history?
No.
Where is Neil Armstrong buried? You'd expect him to be buried at Arlington National Cemetery. He's buried at sea off the coast of Florida. Right. He was a naval pilot in his early career, so he legitimately could request a naval burial at sea. It just seems a bit strange. I don't know. He was a very private person, Neil Armstrong. He didn't like the circus that other people got surrounded by, and he was a university professor for many years in Ohio.
I'm still frustrated because, when you look at all these photographs, you look at all the stories of the astronauts, not many of them would talk about their experience on the moon. And why wouldn't they?
Well, if they weren't there, they couldn't describe it very well, could they? That's being slightly cynical, because many people in America genuinely want to believe that Apollo missions landed on the moon. And they get quite upset when somebody like me comes along and says, no, excuse me, it didn't actually happen the way we were told. Now, NASA are the only people who have the ability to tell us what happened, because they were in radio contact and they were controlling the whole thing. But as the New York Times said in 1968, NASA, never a straight answer, because that's what they were coming up against. They couldn't get a good answer from NASA some of the questions they were raising. This is just before Apollo 8, which was the first mission to allegedly orbit the moon. It didn't land, but they read from the book of Genesis. That caused a bit of a stir. NASA will not address these questions. I've sent queries to them asking them specifically about the spacesuit. What radiation protection was built into the spacesuit? Because obviously it worked. The astronauts were on the moon and they got back and nobody suffered radiation sickness. So could these same spacesuits be used by technicians to go into Chernobyl, 3 Mile Island or Fukushima and clear up the mess? Because at the end of the day, radiation is radiation. I'm still waiting for the reply. I haven't had a reply.
Well, good luck on that, because, NASA said they would have one of their representatives come on my show. And then, all of a sudden we didn't hear no more from them. Then we contacted them numerous times, and all of a sudden it's like we don't exist anymore. Maybe they're scared to come on because they figure out what type of questions I might ask them. Well,
I'm not surprised that they would be reluctant to be grilled, because I doubt there is anybody working at NASA today who was working at NASA during the Apollo years. That's 1961, after President Kennedy made his famous speech in Congress in May 1961, land a man on the moon before the decade is out and return him safely to the Earth. That was his speech. And just over 7.5 years later, they'd achieved it. Extraordinary. But nobody at NASA actually knows the problem. And it's interesting now, we're watching NASA, a lot of people are watching NASA now, trying to return to the moon, as directed originally by President Trump in 2019. Should return to the moon by 2024. That was his timetable. NASA have now put that date back to 2028. What's going on? Couldn't they just use what they used on Apollo and just get there and back? And it must be very simple. It was done over 50 years ago.
Marcus, here's another thing. My dad was a electronic engineer down at Boeing Aircraft. He helped develop some of the electronics they were going to use in the SST, the Super Transport. And my father was an electronic inventor. And I remember talking to my dad about, did we actually go to the moon with the type of computer systems they had? And my dad laughed. And he said, I'm going to be honest with you, son. We didn't have the technology. The computers didn't have the technology to be able to do what they're supposed to have done and got us landed on the moon and all that stuff. I don't know. I'm just going with what my dad said, because I've been in electronics all my life. I had my ham radio license at 12 years old. I mean, I have doubts that we actually had the technology to get to the moon, to do what we had to do to land, and to be able to get back up and then mate with the capsule and then come back.
That's a very good point. I think your dad was being very honest with you. He obviously understood what the problems were. You asked him a legitimate question and he answered you as honestly as he could. People have now done a lot of research into the electronics that was used on Apollo and have come to the conclusion that it didn't work the way we were told it worked. There is so much of a mystery going on. There's one question I usually ask anybody who has any knowledge of electronics or television is, we're told we were having live television transmission from the moon. Now, what power would be required to do a live television transmission from the moon?
Not very much, depending on the frequency it's transmitted. You know, being an amateur, a lot of my friends were running kilowatt of power to talk around the world. I went the opposite. I was transmitting what they classified under 1 watt, and I could communicate around the world. So sending a signal from the moon, a TV signal, wouldn't take a lot of power. But again, the equipment back in the 60s, I don't think, again, it was capable of doing what they claimed it did. I sometimes wonder if it was done in a sound stage.
Interesting you should say that, because people have often said, well, obviously the person who created all these fake images was Stanley Kubrick. I don't think that is correct. I don't think Stanley Kubrick had anything to do with it. But I think somebody working close to him might well have had something to do with it, because Stanley Kubrick was a film director, a brilliant film director. Some of his films are the classics of the 20th century, like 2001: A Space Odyssey, still the definitive sci-fi space film. Full Metal Jacket, Dr. Strangelove about nuclear bombs, which don't go off, by the way. So Stanley Kubrick was a brilliant film director, but the reason that his films were so good was because he had very, very good special effects people around him who could create images. There's a story of him working on Dr. Strangelove, and he wanted to borrow a B-52 bomber, which is what carried the nuclear bombs at the time. This is in the early 60s. So he approached the US Air Force and said, can we borrow one of your planes, please? Normally they're quite happy to lend it because it gives a certain publicity. And they looked at read his script, and they said, no, you can't use it. We're not interested in being associated with the sort of film that Dr. Strangelove was. So Stanley Kubrick, being not one to be put off by stories of refusal, read up as much as he could about a B-52 bomber and the way the instruments were laid out, what the cockpit looked like. He got this all from publicly available magazines, books, information, and he created his own B-52 bomber. And when the film came out, the US Air Force said, "But we told you couldn't have one of them." And Kubrick said, "No, I built it myself. This is how I did it." So he was certainly capable of doing extraordinary things. Now, the person I think who may well have been associated with the Apollo missions was his special effects director, Douglas Trumbull, who worked with him on, obviously, 2001: A Space Odyssey, Back to the Future, also many of the films of the 60s which required models to be made. There was no CGI back then. They used models, and they used periscope cameras which could film small objects or small images and be projected onto a screen as if it was full size or life size. The film I referred to that demonstrates how this was achieved is a film called Make Believe, Smoke and Mirrors. It was released onto YouTube about 5 years ago. It's no longer there. It's on BitChute and it's on Rumble, but it's not on YouTube anymore. It was removed about 2 years ago at the time of the 50th anniversary. So obviously somebody thought it was getting a little bit close to the bone, close to the knuckle, as we say in the UK. It was too near the truth, so it got erased. Well, fortunately, people have archived it, and there's a website I can tell you about where you can go and watch it. So that film is 2 hours, 44 minutes long, the whole film is split into sections, and it describes how all the various films and the photographs were taken. It was done on a film set. Quite a large film set. Of course, the lunar lander didn't have to move, so that could easily be a model. Once you know what to look for, things become obvious. And one thing to look for is consecutive photographs of the same astronaut. These are still photographs, consecutive photographs of the same astronaut. And if you look at them in detail, you'll see the astronaut is in exactly the same position from one photograph to another. Now, that is unlikely to happen as well. And the other problem with astronauts on the lunar surface is we're told the moon has 1/6 the gravitational attraction of the Earth, which is correct, which means that the average human would weigh 1/6 of what he does on Earth. A human weighs about 180 pounds. He has about 180 pounds of equipment on him, his spacesuit, his backpack. So he would weigh about 60 pounds in total. But his muscles will be exactly the same power as they would on Earth. So he could move much faster. This idea that they moved in slow motion is nonsense. That's because they trained underwater, and you can't move fast underwater. But anyway, if you're on the moon and you weigh only a third of your normal weight on Earth, with all your equipment on, it'd be like walking on ice. You wouldn't be able to maintain your balance very easily.
Here's another thing, Marcus. I saw pictures of the footprints. And if you weighed quite a bit less, I wouldn't imagine that the footprints would have been as deep of their boots.
No, that's a good point. Also, if you look at the photographs of the lunar lander, on the moon it weighs about 3 tons. So you've got 4 legs, so they're each exerting about 1 ton of weight inside the regolith, inside the lunar dust, and you can see it's quite loose because astronauts' footprints are all around it. There are many things which don't add up. As I say, this film, Make Believe, Smoke and Mirrors, explains how all the photographs were taken, how all the film was taken. It wasn't slow motion. They used what's called an optical printer, which is like a photocopier for film. So you could take one frame or every other frame or every third frame and create a new film, and it would show slightly differently. There are different speeds, different film sizes we use, from 70mm down to 8mm. So you've got this effect of slow motion. The closer the camera is to the activity being filmed, the less slow motion you require because it'll look too odd. And if you start looking for it and you know what to look for, then it starts to make sense. It was highly complex. Now, my particular view about where all this was actually done You've heard of somewhere called Laurel Canyon, north of Los Angeles?
Oh, yeah.
All right. In the 1960s, in Laurel Canyon, was a U.S. Air Force station. It was called Lookout Mountain Laboratory. It was a film laboratory. And I would suggest that that is the location that a lot of this work was done. When it required live action, it was probably filmed in what's called Hangar 1 near Menlo Park, which is a big airship hangar. Still there today, you can see it. It's on Google Earth, you can see it. Just put Hangar 1 Menlo Park and you'll see it. It's a huge thing. It's where Tom Hanks filmed his mini-series From the Earth to the Moon, because you've got a big enough interior location, you can control the lighting. So there are answers to many of the questions that arise on this. Now, I mentioned that there was another problem than the radiation in space which affected photographic film. Something which also affects photographic film is the vacuum of space. We all know that space is a vacuum. There's nothing there. It's a vacuum. And the further away from Earth you go, the harder the vacuum becomes. When you get to the moon, you've got a very, very hard vacuum, much harder than it would be at the International Space Station. Now, vacuum is measured in something called torr, T-O-R-R. It's named after the Italian scientist who in the 17th century developed the barometer. Evangelista Torricelli, his name was, hence torr. At sea level here on Earth, the torr level is 760. Anybody familiar with meteorology will know that that is the equivalent of millimeters of mercury, which is what we get in a barometer. When you get to the top of Mount Everest, which is only about 30,000 feet high, 5-6 miles, you've got 180 torr. When you get to the Kármán line is the agreed position where space begins. It's about 60 miles up. The torr level there is 10 to the minus 3. It's getting very small. 10 to the minus 3 is 1,000th of what it would be if it was 1 torr. 10 to the minus 3 torr is 1,000th. When you get to the International Space Station, it's about torr 10 to the minus 6. When you get to the moon, it's torr 10 to the minus 12. It's so small, it's almost impossible to measure it. But what it does, there are two effects of a vacuum. One is called outgassing, and anybody who's done that great little experiment where you get a bell jar and you attach it to a vacuum pump and you reduce the pressure inside, create the vacuum, put a bowl of water there, it'll start to boil. It's called outgassing. The lighter elements are pulled from the material there. It can also, when it's a really hard vacuum, as it is on the moon, it can pull lighter elements out of metals, pull hydrogen, helium out of metals, which then look for somewhere to adhere to, and they find something close by, and it's basically like welding, hence cold welding. Now, photographic film is a plastic backing coated with emulsion, a light-sensitive liquid. Obviously, it's dry when it's on the film, or you get a messy camera, but it still started life as a liquid, and it will outgas. And if it outgasses, the film becomes unusable. Now, some friends of mine in Canada, Scott and Robert, set out to demonstrate this, and they bought a commercial vacuum chamber. And sure enough, a film put in a vacuum chamber, put in there for 24 hours, which is the equivalent of being exposed on the moon to the vacuum once the lunar lander is depressurized, put that film into a camera, take photographs with it, and sure enough, to relatively low level of vacuum they were only able to achieve, about torr 10 to the minus 3, it's about 60 miles up, the film was completely shot. The color balance was shot, the blues weren't right, the reds weren't right, the greens weren't right. So if photographic film is damaged in a vacuum, how come we're seeing all these iconic images taken with color film on the lunar surface? No, they weren't. They were taken here on Earth under controlled studio conditions by a professional photographer. So how do we know that photographic film is damaged? 3 or 4 years ago, I attended a lecture in London. I'm a member of the British Interplanetary Society. It's based in London. It's about 90 years old. It's a space advocacy group. They encourage space exploration. Patrick Moore's a member. He was the famous astronomer in London, Arthur C. Clarke, who was a scriptwriter on 2001. He was a member. I'm a member, so I'm up in good company. And one of the talks that they organised was with the designer of the camera system used on the Hexagon spy satellite, KH-9. 1970 it was launched. And that used photographic film. And the designer of the camera, his name was Phil Pressel, said, almost in passing during his talk, well, of course, we had to keep the film under pressure in the spacecraft. And he showed the complex system of tubes and controls and the pressurization with nitrogen gas to ensure that the film was not damaged. About 1 pound per square inch, it's all you need in space. But it had it. It had it on this camera. Now, I knew there was another spacecraft that used photographic film in space, and that was the Lunar Orbiter. Not to be confused with the Lunar Reconnaissance Orbiter that came in 2009. The Lunar Orbiter was sent to photograph the moon looking for Apollo landing sites in 1966, and that used photographic film. It was processed on board the spacecraft using a type of Polaroid system. The developed negative was then scanned, transmitted back to Earth, and the picture reassembled on Earth. And there's many, I've got several of those pictures already. They're very good pictures. But if you look at the schematics of both the Lunar Orbiter and the Hexagon, you will see that the camera systems are contained within a pressurized environment inside the spacecraft. Because I asked Phil Pressel after his talk, I said, would the same requirement be necessary with Apollo? He said, of course it would. Film is damaged in a vacuum. And that is from somebody who knew exactly what he was talking about.